Now that we have the schema for the website and the developers, let's go back to Java to communicate with MySQL. So in CS5200 lecture, we want to communicate with those two using Java. So we're going to need a library here. We're going to do it directly. We're going to connect to the database directly, right, without going through any infrastructure. Just our Java class directly to the database. So to do that, we're going to need to add an additional library to the project, right? And it's that library, we put it in the user local lib, right? This is not the one that Tomcat is going to use eventually, right? This is our own library because we're bypassing Tomcat. We're directly connecting to it. So we're going to go into the build path and configure the build path and tell it to add an external jar file. And it's already in the correct directory. It's already in user local lib, right? We're going to add it in there so that our classes will compile, right, using these library, right? So this library implements an interface. It implements the jdbc interface, right? Which we'll be using today. Okay. So here's an example on using that jdbc interface. Right, so we created a dynamic web, we gave it a name, we added the external jar file, and let's create a very simple jdbc program. Right? Let's create a class, and from there we'll communicate with the database. So let's do that. So let's create a new class, and we'll call it lecture, and this will be just jdbc and then test. And we'll call the class jdbc test main and create it. All right, so we have our Java application, and this is a plain vanilla Java application. There's nothing interesting about this. We can just have our simple hello world. This is system.out.println and have here just hello world. All right, so this is a plain vanilla, plain Java object, and we can ask to run it as a Java application. So it's a standalone Java application, and it writes hello world to the console. Nothing peculiar about it. Okay. All right. So we first want to be able to connect to the database. So to do this, right, we need to get a hold of the library that we're going to be using to communicate. Right. In this case, is MySQL. Right? And this is where the only place where you'll see that indeed we are using some kind of vendor, right? Ideally, the configuration of what vendor you're using would not be actually inside of the source code, right? Because if ever we need to change the vendor, we would need to go in and mock with our source code, right? And the whole point of jdbc is that you are vendor agnostic, right? But first, let me show you what's behind the curtain before we configure it outside of the source code. All right, so let's do that. We're going to load the library. So to load the library, we're going to be using several jdbc classes, right? The jdbc library is all implemented under the package java.sql. Right? And these are all interfaces. There's no code behind these classes. They're not classes, they're interfaces, right? And the whole point here is that the vendors implement these interfaces, right? So that as far as you're concerned, right, you're getting some class which you don't know what it is, you don't even care what it is, right? That implements this interface, right? That has the right functions with the right signatures, that it has the right behavior according to the documentation. So first, let's load the driver manager first. Right, so let's copy that and let's paste it in here. All right, the driver manager is going to allow us to load the particular driver that we want to use, right? And all the major vendors have their own particular drivers, right? And you can swap between them if you stick to the standard JDBC code library. Then it should be fairly easy to migrate from one vendor to the next, right? The vendors, it's good and bad for the vendor. Obviously, it's a low bar of entry into using a particular vendor, but it makes the vendor somewhat of a commodity, right? It's if you don't really care which one, you won't necessarily be loyal to any one particular vendor, right? It's almost like when you're going to put gas, right? You almost don't care, who the vendor is. So gas becomes a commodity, right? You're not willing to pay more for the brand, perhaps, right? So oftentimes vendors try not to become a commodity, right? Just like also airline tickets. Just give me the cheapest. I don't really care which one, right? So they try to create a relationship, a long-term relationship with their customers, that they can upsell them, or they can have repeat sales for the same, and have a more long-term health of their finances. So what their vendors will try to do is that they will implement the core JDBC standard, but will also go beyond the standard. Right? Will provide certain features that are specific to that vendor. Okay, and they will market it really heavily, saying, "Hey, we do JDBC, plus we do this other stuff. Try these other features." Right? But again, if you go away from the standard JDBC, then you become dependent on that particular vendor. It'll be much harder if you ever want to move over to another vendor, right? So it depends. It depends what the overall strategy of your company is, if they're going to stick with one particular vendor or not. All right, so let's grab this particular vendor. And first we'll need to know what is the class that implements the driver, the JDBC driver. This is the entry point class, right, from where everything else is instantiated. Right, so this is the entry point. Right, so let's grab that string, right, and let's declare it there. Okay, so this class implements this interface. Right? That's the interface, java.sql.driverManager, and that class implements that interface. And we're going to load it, right, with using a plain old Java class loader. Right? For this to work, this class needs to be in the class path of this one file, right? And we did that already. We added the jar file into the class path, right, by adding this library. By adding this library here, this jar file, now it is in the class path. It will find that one class, right, com.mysql.jdbc.driver. Right, so that class is implemented in that jar file, right, and it finds it because we added it. Otherwise, it would not have found it. Okay. All right. Now that it's there, we're going to load it using a simple class.forename. Class.forename. Maybe I should make this a little bigger. I'm going blind. 24. Okay. There it is. So I loaded it. It's complaining, saying that this throws an exception. So I'm just going to add it to the declaration. Class not found exception. Right? I'm lazy. Usually you put it in a try catch. Right? I'm just throwing it, rethrowing it. What else? Let's see. Now that it's loaded, we can now. What this does is that it adds this driver manager instance, right? It's now available as an instance variable, and we can just use it now as a static instance, right? and we can say we can use the driver manager dot get connection, right? We can now go and ask for a connection to a database, right? Now, get connection has several versions, right? If your database doesn't have a username and password, you just need to know where is it located, where is it running, where's the server running. At least it needs to know that. Where is the server running? It needs to have a URL of connecting through the network. Okay, so at least it needs that. Okay, so we need a URL. So let's go fetch the URL. The default URL. Okay, so JDBC uses a standard URL, right? That has a specific protocol, right? It's not HTTP, it's not FTP, right? It has its own protocol, right? It's called the JDBC : and then the vendor, the name of the vendor, right? So this will be different depending on the vendor you're using, right? And the vendor will document it. It'll say it's this is the protocol. They should all start with JDBC : and then whatever the vendor wants. Also, it's running on my local machine, right? If this is running elsewhere in some other server, you'll need the IP address of where is it running. And if I don't provide the port number, then that means it's using the default, what is it, 3351, whatever, I forget. The port number where MySQL typically listens for incoming requests. And this is the name of the schema that you want to connect to. In this case, we are going to connect to, where are we connecting? The lectures here, right? We're going to connect to a lecture. So we're going to replace this with lectures, because we're connecting to that particular database. All right? Okay. So I'm going to use it right there. And now, so that's if the database doesn't need a username and password, that's enough. Okay? If it needs a username and password, you can pass them along here as well. Right? Ours does need a database, a username and password, which is CS5200. So I'm just going to copy them over, and I'm going to pass them here as arguments: username and password. Okay. And notice that it's complaining. It also throws several exceptions. Right? So I'm lazy, and I'm just going to rethrow the exception. Right? It's a SQL exception. Here I'm going to now grab that connection that I just grabbed, or that I just instantiated, and I'm going to assign it to a local variable connection. The connection is part of the JDBC. Notice that it found the MySQL.jdbc implementation. You see that? Right, that is MySQL's implementation of the interface. We don't want that one. Right, again, we want to be agnostic as much as we can from the low-level implementation. If you import this one, it would work fine. This would work just fine. Right? But we don't want to use a concrete class. Instead, we are going to use the, where is it? The interface. Java SQL, that one. There it is, java.sql connection. The class that implements that interface is com.mysql.jdbc.connection. Yes? All right? Okay, so in fact, that connection variable is of type com.mysql.jdbc.connection. Right? But the whole point is that I don't want to use that. All right, now that I have the connection, we can now start connecting. And the way we connect is that we create a statement, right? SQL statement. And for instance, we might create a SQL statement like so, saying that I want to select everything from the from developers. Say, let's see, what do we have here? We have developer. We have two developers. There they are. And so it's the table developer. So from developer, that's it. That's the SQL statement. well, the string of the SQL statement, but we need an object to actually execute this, right? So what we do is that we ask the connection for a statement, create a statement object from the connection. And we're going to assign it to a local variable statement of type statement, right? Again, this is also part of the jdbc interface, and we're going to include not com.mysql jdbc, but instead the java.sql. Yes? All right. Now that we have that, we can now execute the statement. We can say statements dot execute query, and we can pass in the SQL query that we want to execute. And this query, if we hover over it, it says that it returns a result set. Right? The result set is going to contain the collection of rows that match that query. So this returns a result set that is also part of the jdbc library. There it is. Now that we have the library, the result set, okay. What if this had thousands of records that match, right? It makes sense to have thousands of records stored on a hard drive. Yes, gigabytes of records that meet that criteria, but it makes no sense to have gigabytes of data instantiated in memory of this application, right? It would just blow up. Instead, result set is smart, right? And it doesn't return all the rows. Instead, it fetches, right, several rows into memory, right? And it gives you the illusion that you are using all the rows, that you're iterating over all the rows one at a time, right? And all this is abstracted from you. It fetches 10 rows, right? And when you're done iterating over the 10 rows, it'll fetch 10 more rows, right? It'll try to cache them. It'll cache them in memory and allow you to iterate through them. Right? To iterate through them, we can use just while rs next. Next fetches the next row. Right? At first, we're not at any one particular row. We are at a position called before first. Right? So result says keeps track of a cursor of which row are you actually pointing in the database. Right? The very first time, you're not pointing at anything. Right? You are at a position called before first. Right? To actually start and point to a row, you need to advance the cursor using the next function. Right? The next function will advance the cursor to the next row. The actual ordering of the rows is not guaranteed, right? Unless you explicitly ask to sort them in a particular order. Right? They're not guaranteed to be in any particular order. Typically, they'll come in the order in which they were inserted, right? Historically, chronologically, but it's not guaranteed, right? It's whatever the database vendor wants to do. It's whatever they want to do, in whatever order they want to return the rows. All right, now that we have R pointing to a particular row, we can now start extracting each piece of the fields in the developer. In this particular case, we have first name, last name, password, usernames, and ID. And we can retrieve each one individually depending on the data type. IDs were integers, whereas the other ones were all strings, right? And result set allows you to retrieve one individually particular data type, right? So locally, I can retrieve the ID, okay, and I can say rs.getInteger, right? And here I can say get the integer either by the column index, right? The columns were declared in a particular order. Here we have ID being the first column, username being the second column, password the third column, and so on and so forth. Yes? So you can either ask for them in that particular order, Or you can ask them by name. I want the column ID, the column username, the column password. Right? It's best practice to use the actual name of the column. Right? But if you're writing something that is generic and you don't know how many columns there are, right? You're using some kind of like meta code, right? And you just want to iterate over all the columns, you can do it also by index. Okay. All right, so we can retrieve from the index from the column called ID. And we can retrieve all the other ones. String, first name, well, username, rs.getString, username. We can retrieve the password. And this would be password and first name and this is first name. And this is last name. Okay? Now that we have each one of these, perhaps we can display them. You can say system.out.println. We can say we can display ID, tab, username, and maybe the first name. Let's just do that. It's just first. Okay? After you've done that, you need to close the connection, right? The database can only have so many open connections at a time, right? So after you open them, make sure you close them, right? Otherwise, every time you run this, you're asking for a brand new connection, another brand new connection. Eventually, the database will run out of connection and it'll say, sorry, no more connections. And if it's a shared database that you are working shared with other developers, and some other developer says, hey, why can't I connect to a database? Somebody's not closing their connection. Make sure it's not you. Right? Make sure you close your connections behind you and folks not say, well, somebody's not closing their connections. And you need to close them in the reverse order that you open these resources. All these resources maintain RAM, memory, you're consuming resources from the database and the machine, so you should close them. So rs.close statement.close when you're done, and the connection close. Okay. All right. All right. So let's run this. See if it blows up. And there it is. So we have 1, 2, 3, Alice and Bob, right, from the database. Okay, make sense? Yes.
In the result set, you know that it returns the select star from developer returns a value. So if it's anything but a select query,
yes.
what would it return?
Like if it's an update or delete.
Update or create,
yeah, it returns an int. How many records were affected? If something goes wrong, it throws an exception. If something, confines something or whatever, or you're breaking some constraint, it throws a SQL exception, right? But it normally just returns int. How many records were affected? Everybody okay? Make sense? All right. So we've illustrated being able to just plainly just go fetch just a piece of information, right? Typically. Ideally, what you want to do is instead, populate this data and not work on it in such a raw format. Typically, you want to encapsulate it at a higher level in an object with its own data model and whatnot, and eventually, wrap it around some nice API that interacts, that abstracts, creates an additional abstraction layer on top of this axis, right? All right, so let's work on that.